Good evening. I'm Ganesh. This is my independent variables, and this is the carbon monoxide that I collected data, and this is the air quality index, and this is the data I collected, and there are variable and independent, and to count I B2 to B3, that is for carbon monoxide. For the dependent, I from C3 to C32. So I got the number of data. And then for me, I use equals to average B3 to B32. That's from the carbon monoxide. And then for dependent, I C3 to C32 for the dependent variable quality index. Then for the minimum value, I use mean B3 to B32, that is from carbon monoxide. And for the dependent, I press C3 to C32, that's from air quality index. For the maximum value, I press from carbon monoxide B3 to B32, that is this. Then for the dependent, I use C3 to C32 for the air quality index data. Then lastly, the standard deviation, I press equals to STDV and B3 to B32, that is from carbon monoxide. Then for the dependent standard deviation, I press equals to STDV as C3 to C32, that is from ITIC data air quality index. And then this is the table, and this is for this data. I carbon monoxide air quality index. I press from the highlight the carbon monoxide and air quality index. Then from insert and the charts, then there will be this pop up this table. Then from there we can choose the quick layout that which we want. So they will count and they will come the data in that graph, and this is the graph I attached at here for the data. Okay, for this chart and for the carbon monoxide air quality index, for this one data is linear line for this one. So there is the air quality index axis, and then this is the data. This is for carbon monoxide data. Then the data is y equals to 0.1669 times 12.1 at 0.2361. For this, I got from this chart. Okay, this one for the to get the slope, there is a here for in this table. For the slope equals to slope C3 to C32, that is the air quality index from the 42 to the below this one for this. Then the another one is B3 to B32, that's for carbon monoxide from this. Then after that for intercept equals to intercept C3 to C32, that is air quality index. Then after that for the B3 and B32 for the carbon monoxide, so we will get this intercept. So that's all. Okay, this is the plot scatter diagram. Determine the linear regression line, and this is the data that I took from the Excel. So this shows the carbon monoxide as air quality index, and the plot y equals to 0.1669x, and with 12.1418, and the R is 2R2 square root 2 0.2361, and it's only convert to the percentage 23.61%. And then there's a scatter plot repetition and the regression equation, this both. Then for the scatter representation, the blue dot represents actual data point of ratio of CO concentration of AQ. The red dotted in the linear regression linear the attempt to model the relationship. For the regression equation, the slope 0.169 suggests the positive, and then for also increase through weekly, the intercept 12.1 for air suggests baseline AQ1 CO conditions to is 0. And then for the coefficient of determined R square 2, the R square is 0.236, and in percentage 23.61% for variation equals suggestion factor such as VDC temperature, humidity, equal impact. For the data spread outliner, the data point where it is scatter into a very big correlation. Some point deviation basically the trend line suggests a quotation outlier. Assuming linear relationship is square method of the find the simple linear regression model.
So now I'm going to show you about how to get the simple linear regression model in Microsoft Excel. So first we go to data analysis, in regression. So in input Y range, we selected from independent variable all the 30 data, which you can see here, B2 to B32. Input X range, we selected air quality index dependent variables from C2 to C32. So the B2 and C2 will be named as labels. Then we also add residuals. Then we click OK. So this is the summary output. The summary output, this is the same as we see in the sheet 6. So this one I worked earlier. So you can see the multiple R value, R square value, standard error, and here in ANOVA we can see the F statistics, significance F values, and other than that we can see here. So this is the residual output. For residual output we can see the predicted air quality index and the residuals. So in this question we need to check the significance alpha equal to 0.05 of the simple linear regression model in C, which I showed just now in Microsoft Excel. So the given data in from the regression model F36 is 8.65437561. Significance F is 0.006843462. The alpha value is equal to 0.05. So the decision rule is if significant S is less than alpha, we need to reject HO. So the evaluation will be significance F equal to 0.0068433462 is lesser than alpha value 0.05. So the conclusion at alpha value 0.05, the regression model is statistically significant, which means that the independent variable significantly explains the variability in the dependent variable. For this question, we need to test the hypothesis H1 beta 0 is unequal to 0 and H1 beta 1 is unequal to 0 by taking 5% level of significance. So the intercept of beta 0 will be data from the regression model, coefficient data, t-statistics data, p-value data, and slope for beta 1 will be also taken from regression model, coefficient data, t-statistics data, and p-value. The significance level is A 0.05, alpha equal to 0.05. So the hypotheses are followed by this here. So the decision rule will be if p value less than alpha, we can reject H0. So for evaluation for beta 0 intercept, p-value is equal to 0.18922, which is more than alpha 0.05. So it's failed to reject H0. Conclusion, the intercept is not significantly different from 0. Secondly, for beta 1 slope, p-value equal to 0.006843462, which is less than alpha value 0.05, so we can reject H0. Conclusion, the slope is significantly different from 0. The conclusion for all over it will be the simple linear regression model is significant at alpha equal to 0.05.
So this video about residual output, then this is predicted air quality index and residual. How we get the output by resolution mode. To get the chart, select all and press index and press the chart. It will pop up, but in recorded it show never show. Press the first one diagram and it will show up like this. After that, press the quick layer, press the 9, it will change like this. This method are used for here also. They are same method. Thank you. In this video, to plot this diagram, carbon monoxide independent variable and resolution, select all and press insert and press chart. Check the diagram chart, it will show up like this. And press quick layout, means you will get a layout like this. And this is residual versus independent variable. And independent variable, this is s and y. The point called as residual. The value get as a predicted air quality index and independent variable. For residual variable are similar, evaluate from the second pilot. Residual was prediction at quality index. The separated of residual appearance inconsistent across different predicted value at some predicted value. The separate is wider, while at another it narrowed. This indicated heterosidicity, not constant variable. Violating this assumption, for the conclusion, residual variables are not similar. Residuals are normal distributed. A formal normality test like a Spirovoil test or histogram of residual will be required for definitive conclusion. However, based on the scatter plot, the residual seems to chlorotress irregularly, which may indicate not normal distribution. For the conclusion, additional tests are needed to confirm normality, but the visual analysis raised concern. Residuals are independent of each other. In the third plot, residual was independent variable. They does not seem to be systematic maintained in the residual. This suggests that not residual are like independent. For the conclusion, residuals are like independent of each other. The last is acceptance of significant outlier. In both the second and third scatter plot, certain points are notable distant from the rest of the data. Those points are potential outliers that could be disproportionately influence the regression model. For a conclusion, significant outlier as it which could affect model performance.
So I would like to do the t-test for the given data. So firstly, we'll go to data. In data analyst, you will select the two variable occurrence, and then we have to set the range 32 for carbon monoxide and the air quality index. Okay, after setting 32, we will click the label and the alpha value will be 0.05. And then, so this is the result that we got. And as we can see, the mean for carbon dioxide and the mean for the air quality index. So from the t-test, as you can see, we will get the value of variance and standard error using the formula SQRT, and the observations standard error, same for the formula SQRT. These are all the values generated, and in order to get this uh, mean rate standard error data, we click this insert bar chart, and so we're supposed to get the chart title. Some correlation coefficient is calculated by using the formula Pearson B32, which is carbon monoxide 32, and C32, which is the air quality index 32. And by substituting this formula, we can get the Pearson correlation coefficient, which is this value here.
Now I have three questions on the slide on the report. So the question number one is, how does the Pearson correlation coefficient help in understanding the relationship between carbon monoxide and the air quality index?
Yeah, hi, good evening. My name is Sailesh Analaki Gopal Krishnan, metric number CE210068. So, based on the question, the Pearson correlation coefficient, which is R equals to 0.59, measures the strength and direction of linear relationship between carbon monoxide levels and the air quality index. Since R is positive, it indicates a moderate positive correlation, meaning that as carbon monoxide level increase, the air quality index tends to increase as well. However, the value is not close to 1, suggesting that other factors besides carbon monoxide influence the air quality index. A higher R value would indicate a stronger correlation, which a value closer to 0 would suggest a weak or no correlation. Thank you.
So the second question is, what does the coefficient of determination indicates about the regression model predictive power?
Hi, my name is Devinish Analaki Kanirabani. My metric card number DE210015. Based on the question, the coefficient of determination R power of 2, 0.2361 indicated that only 23.61% of variability in the air quality index can be explained by carbon monoxide level in the regression model. This means that carbon monoxide has some influence on air quality index, but the majority, about 76.39% of variation, is due to other factors such as humidity, temperature, VOC, or particulate matter. A low R power of 2 suggests that the model does not have stronger predictive power and should be improved by including additional independent variable. Thank you.
So the question number 3 is, why is the significance of regression model important, and what do the t-test result imply about the model?
Hello, my name is Hari Puthiran Kannan. Metric number is DE210008. The significance of the regression model is tested using the f-statistic and its p-value determines whether the independent variable significantly affects the dependent variable. The f-statistics equal to 8.654 and the p-value equal to 0.0068 indicate that the regression model is statistically significant at alpha equal to 0.05, meaning carbon oxide levels have a significant impact on air quality index. The t-test results show that the slope beta 1 equal to 0.1669 is significant, p-value equal to 0.0068 less than alpha value 0.05, meaning the carbon oxide levels contribute meaningfully to changes in air quality index. However, the intercept beta 0 equal to 12.418 is not significant. P-value equal to 0.189 is more than alpha value 0.05, implying that the baseline AQI when carbon monoxide is 0 is uncertain. Thank you.
So
That is
from my questions.
So that is all from us. Thank you.
Thank you.